Good evening and welcome. My name is Dominik Schrage. I'm professor of sociology here at TU Dresden. And my job here is to present our guest, Elena Esposito. It's a great pleasure to present her here in this context. Elena Esposito has been writing as a sociologist coming from system theory, on a really impressive amount of different topics. And the common ground of all these topics seems to me time. So it's temporal problems that you have been working for the last decades. And now she's working on a project, or has been working on a project on artificial communication. This is also the title of her speech this evening. And that comes from a 5-year ERC grant. And there will be a book about this topic, and it's announced for next year with MIT Press with the same title, Artificial Communication. So what you'll present here will be, I hope so, something that gives us an idea about the book that will be published soon next year. Elena Esposito is a professor of sociology at Bielefeld University and at the same time at Bologna University. Maybe later you can explain me how you do this. I find it very impressive. Okay, and besides, she has, before she worked at University Modena e Reggio Emilia for quite some years, and she studied sociology and philosophy and made the PhD with Niklas Luhmann in Bielefeld and the Habilitation as well in Bielefeld. It's impossible to name the huge number of visiting assignments, fellowships, and awards. I already mentioned the 5-year grant of the ERC for the project she will be talking now, this evening. Just a short glance on other topics. I know her book on fashion. The German title is Die Verbindlichkeit des Vorübergehenden, Paradoxien der Mode. It was a book that was for me very important when I was working on fashion and consumption. And she also worked on the time of money in financing and society, the future of futures. That's the book after the fashion book. And only 2 or 3 titles I wanted to mention here just to show that Elena Esposito is not only working on artificial intelligence, but on quite a lot of topics. And for those who have already been working with the system theory, she is the co-author of GLU, of the Luhmann Glossar, what is a very, very important and very helpful thing for students that are approaching the system theory of Niklas Luhmann. So maybe for some of you, this will also be an interesting information. Thank you very much, Elena Esposito, and we will have a discussion afterwards and after the talk, so there will be the possibility to ask questions or to get some input in the discussion. Thank you very much.
Thanks, Herr Schrage, für diese so freundliche English, sorry. Thank you for this kind introduction. Thank you to Mr. Gross for preparing all the thing and organizing the event. It's really a pleasure to be here. Shall I try to share the screen now? So we have. Okay, it works. Can you see that? Oh, great. So wonderful. Yeah, as Mr. Schrage said, I will talk about artificial communication, and that refers to the book that will be coming now, be published now. And it's, of course, for me, it's a big pleasure to talk about this topic in the context of this conference on artificial intelligence in the social sciences. It couldn't be the better place to discuss it. And I'm really looking forward to your feedback because I will see my talk about artificial communication is, my work on that, is an effort to think about the issues dealing with the artificial intelligence from the perspective of the social sciences. And the result, it's, you will see, probably partly controversial, so I'm really interested in the feedback from people working in the field. You, Herr Schlage, kindly mentioned that I tended to work actually without noticing it, usually with the issue connected with time. I say without noticing it because it happens to me, I think, or to several colleagues, that the coherence of what you've been doing becomes clear afterwards and not the beginning. So I pick up topics quite diverse, actually. Fashion and the finance markets, and I've been working on memory, on well, several different things, and algorithm and artificial intelligence. I worked on probability and so on, because I simply found the topic interesting. And then looking back, you find that actually there was a red thread more than I was aware of. And actually, I think it's time. And time is also, as Mr. Schlage said, the topic of the research project that we are, with my collaborators, we are developing on the question of prediction, which of course is related with time. But what I will say today is will really be focused on the topic of the conference. So we can talk in the discussion how it's connected with time, but time this time won't be the main topic, because what I really want to discuss with you is how we can understand that today, after more than 50-year discussion about artificial intelligence, the issue from a sociological perspective. So the question is, of course, are algorithm intelligent? Have they become intelligent? Is the right way to deal with the issue? Because, you know, artificial intelligence is nothing new, and the research about automatic information processing has also always been guided by the ideas that machine could, should, possibly can reproduce a human intelligence. And the very label of artificial intelligence reproduces that. One tries to reproduce with machine the working of the human mind, and that has always accompanied the process of digitization of working with computer since at least the end of the 50s, when the research began. And that was, you know, work in the field, there were repeated winters and springs, winter when the things seemed to go well, and spring when bad, spring when they had the pressure that was going well again, and so on. So what's happening now? Because now many people speak about a sort of a reviving artificial intelligence. We are definitely in a spring. The research on artificial intelligence has a big momentum now. And actually, the advances in the field are actually impressive. When we talk now of algorithms rather than computers, I will say later something about that, about the change. But the idea is basically the same. To try to have machines that do the same thing that we do with intelligence. And actually, it seems that we are reaching now impressive results. Algorithm can do now many more things and do them much better. Also, typically the things that tradition has been a prerogative of human beings, so of beings which are intelligent. So, for example, you know, algorithm we experience every day, can answer the phone, can give information, they can carry on conversation, they can write text, and text that often cannot be distinguished by text written by human authors. They can even compose poems, as I unfortunately couldn't be present, but that's what they discussed in the part of the conference today on the techno-poetology, and that's what algorithm can do now. They can write music, they can produce images, They provide psychological counseling and many amazing things. Before discussing the question of intelligence, I would want to quickly address the issue, why now? Why are these accomplishing? What is new now in this new spring? And I think that you know, certainly working in the field, but I will quickly mention them. What happened in the last, let's say, 10, 15 years that gave this new impetus on artificial intelligence, on the accomplishment of the machines. I think that these impressive results depend on two developments. They are interrelated. One is a little more traditional, one is rather new, but they both are sort of contributing to this new development. The first, of course, is the enormous advancement of machine learning. And I said that's not necessarily new because machine learning is by itself nothing particularly new. It also had accompanied the development of computerization, digitization since the very beginning, and also with ways of success and failures and so on. But today seems to be a new moment on machine learning. Machine can learn, but algorithms seem today not only to be able to learn, but to learn by themselves, to learn autonomously, and to decide autonomously how to learn and also what to learn. You know, the technique that I discussed now, the new forms of so-called unsupervised machine learning, or the mysterious, fascinating field of so-called deep learning, where a machine can perform tasks, can learn themselves how to perform tasks that were not planned by their programmers, and the way in which the machine learns is in many cases also incomprehensible to human beings, even to the very designer that programmed the machine. Talk with machine learners, the people working on them, they also explicitly say they don't understand how the machine they program works and how the machine accomplishes the task that it's been assigned to it. So that's a huge field, and that's something really new going on. But I said two developments. There's a second development that's deeply connected with machine learning, and without which machine learning wouldn't work. And that's already hype, something, again, hype, something very much discussed, the so-called big data. So the huge amount of diverse, strange, not structured, in any case, data that are available today for machine operations. Machine learning couldn't work without big data, and if we didn't have machine learning, big data would be very, very difficult to process in a sense. So the two things are connected. But it's not clear what big data actually are. The definition of big data is quite open, complex, controversial. You might have heard that the many V's that people are saying, velocity, variety, and so on, but it's not so clear what's meant with that. What I think is quite uncontroversial, and in my opinion, most researchers agree on, that this new kind of data is connected with the spread of the Web 2.0, or the so-called participatory web that we have not by chance since, let's say, the last 15 years. Participatory web because we participate in the web. So everybody, the user, is not just using the web, but participating in that, producing big data because everybody produces a lot of data. Either voluntary, when we, on purpose, let's say, rate things, introduce something, upload something on the web, comment, and so on. But in many cases, also without being aware of that. With our behavior, with the navigation and choices we make on the web, with our participation in social media, but also with all the data collected by GPS from our GPS phones or the sensor of so-called Internet of Things, all devices that produce a huge amount of strange, diverse, uncoordinated data that flow into the undefined field of so-called big data. The results of this innovation is, I think, what I quickly mentioned at the beginning, that now the machines can perform really complex tasks that up to some decades ago were required human intelligence, required the competence of human beings. So going back to our question, if now machines are able to perform these tasks autonomously, should we conclude that the machines have now become intelligent? Or are algorithms nowadays, with this new wave, with machine learning, with big data, finally fulfilling the dream or the nightmare of artificial intelligence, what people have been imagining since the 50s? That's what many people say, but that's not my opinion, and that's what I would like to discuss with you. I don't think that we are reaching machines that are becoming intelligent. On the contrary, it seems to me that this very development shows something that goes in a different direction, that the very idea of artificial intelligence is no more adequate to describe what's going on now. We need a different kind of metaphor to describe what's happening with the new algorithms. And that's connected with the way the algorithm works. Because if you look at the way this new advanced, refined, complex algorithms work, you can see that intelligence is not the point and not even the purpose of these algorithms. I say these machines can do such amazing things, the one that we usually do with intelligence, not because they finally become intelligent, but paradoxically, I would say, because they are no longer trying to be intelligent. They are doing something else. Or one might even say that the advances that we observe today, dealing with the algorithm, do not sign the triumph of the project of artificial intelligence, but in practice, I would say, the abandonment of this very project, the project to reproduce with machine human intelligence. The reason is that the process that drive algorithms are now, since relatively short, 10 years, completely different from the process of the human mind. And in fact, no human mind, and no even combination of human mind would be able to reproduce them, and often, as we say, not even understand them. We cannot understand these processes because they're really different from the process of our human mind, for the human mind. And the programmers in the field say it also explicitly. They, is it working? No. They say, we do not try to copy intelligence. They say explicitly, that would be too heavy a burden and we don't need it. I make an example that I often quote in this field to explain what I have in mind. Think about the classical discuss example of a machine translation, algorithm making translation, that if you remember, the one that not so young, they have all been translators, computer translating languages, but they were really, well, everybody made jokes about them because they were sort of useful, but they were funny because the translation was quite bad and it got some words, but actually the meaning of the thing was never worked. The translation didn't really work. Now they are really excellent. I use them, deep translation, I use them basically every day because I'm lazy, and because the result is actually excellent. Finally, there are something that you would correct, but actually, machines are now becoming able to translate the text reliably from a language to another language. And what happened to produce this result now? The program clearly said that they changed completely the attitude. They stopped trying to teach the machine the languages. They stopped trying to teach a machine the rules, the grammar of different languages, and try to do now something else. The algorithm, for example, the algorithm that translates now text, let's say, from Chinese into English or from Chinese into German, doesn't know Chinese, doesn't know German. And the programmers who wrote the algorithm don't know Chinese themselves. That's not how the machine works. Using machine learning big data, now this machine, you know how it goes in the field. They don't try to find the rules, they try just to find patterns and regularities in the huge amount of text that they can access on the web. And they compare them, they use them to find these regularities and to produce text that from one engine to the other, they are intelligible and make perfect sense to the users. When we read text, for us the text makes sense. Not for the algorithm. The algorithm doesn't have to understand the text. Translating something without understanding produces a text the algorithm doesn't understand, as the algorithm doesn't understand anything of the content they process, in all cases. When they do translation, but for example, think about spell checkers, what we use every day when the machine tells us, did you type something wrong, and they correct it. The machines don't know the rules of the languages. The same algorithm can check different languages because they don't know the rules. They just look for this regularity on the web and produce these results correcting typographical errors. And the same like digital assistants like Alexa and Siri talk with us, but they don't understand the meaning of the word they say. The word simply work. Or the algorithm that write text, I quote from an author of that, don't reason like people in order to write like people. Algorithms don't reproduce the process of our mind. The machine had not learned to think like us. On the contrary, I will say, these amazing results come because they don't try to do it anymore. And that's precisely why they work so well now. I think that we are facing now a way of processing data and of managing information that is basically explicitly and, well, voluntarily different from human information processing and also from human understanding. And my impression is that this difference from of the way machine works from human intelligence is not a weakness, but is the very root of the success of these technologies. I often refer to a metaphor by Hans Blumenberg, probably some of you already heard of it. He said that human beings became able to fly like birds when they gave up the effort, the idea of building machines that mimic birds and flap their wings like birds. Airplanes don't flap their wings, and that's why we can fly every day. They don't try to reproduce, to imitate birds, and then the way we can fly. I would say, for stretching the analogy a little, that's what's happening now, that digital information processing achieved the result that we see today, producing machines that act as if they were intelligent, when they abandoned the ambition, the effort to mimic, to reproduce the process of the human mind. The algorithm do something basically different. Of course, that cannot look very plausible, especially because algorithms now regularly pass a Turing test. And the Turing test has always been considered the criterion for deciding whether the machine is intelligent or not, since now 100 years. You know the test, the idea that a machine passes the test to see if it's intelligent, if it's able to communicate with a human being without the person realizing that this person is, the partner is a machine. If you don't realize that my partner is a machine, the machine has become intelligent. And that's, the test is always used and is still very much referred to. But if you think about it, it's really a very strange test. But in fact, it nowhere measures the intelligence of the machine. It doesn't refer to the intelligence of the machine. The test checks something completely different, checks the ability of the machine to act as a competent and informative communication partner. That's how the process of artificial intelligence went. What we are seeing now, there's a process of artificial intelligence called artificial intelligence that brought to build machines that didn't learn to become intelligent, but to do something else, exactly what we do with intelligence. There's a truly test checks, the machine had learned to participate in communication, which is a different thing. That's why, rather than artificial intelligence, as the title of my talk says, I prefer to talk of artificial communications. What we are observing now is not intelligence by machine, artificial reproduction of intelligence, but rather artificial reproduction of the ability to participate in communication. And the two things are that we may claim they are different. I will say a little more about that, but of course, one could be worried that human intelligence then becomes irrelevant. And I don't think that's the case, because human intelligence is not irrelevant. It remains actually indispensable. It's absolutely required to produce this performance by the machine, even especially if the machine doesn't have to be intelligent. Because these new advanced algorithms are able to compute, combine, process data, process differences in the data that they find in the web with amazing efficiency. But they cannot produce them by their own. They find the data on the web. They find the difference, the raw material they process, they find it on the web. And these materials, the data, are participatory web, are a big part of that generated by the behavior of human beings. So we could say that through this big data, algorithms feed, in a sense, on the differences generated by individuals and their behavior, and they use it to produce new, surprising, and potentially innovative information. They need to have this raw material produced by the behavior of human being, guided by the intelligence, to produce new forms of contribution to communication. So the algorithmic process starts from the intelligence of the users that goes on the web, and that use it to process the result and to operate intelligent, to look intelligent, without, as a communication partner, with no need to be intelligent themselves. That's why, in order to participate in this kind of communication, algorithms need to access the web. That's why only now we have these amazing performances, when the web made it possible for algorithms to access all this data, all this information. This new form of, let's say, artificial communication would not be possible without the web. And actually, the breakthrough came only with the participatory web. The first example, the sort of emblematic example, is Google. Google is always mentioned as the example of the way to work with the web, which of course is before the algorithm, but sort of started using the kind of logic that produced at the end this kind of breakthrough. Because Google, someone remembers, now everybody uses Google, but some decades ago there were other competing search engines like Yahoo, AltaVista, and so on. But Google was so much more effective, successful of them, because I would say it was the first to systematically use this kind of approach that didn't try to reproduce intelligence. That's why PageRank, the basic algorithm of Google, as many people said, invented the internet as we know it today. What was the real innovation? What was the intuition behind this success? PageRank gave up completely and explicitly the idea, you know how PageRank works more or less, but the goal of understanding what the web pages say. And they explicitly relied only on the structure and dynamic of communication on the web. When we search something on Google, PageRank has to determine which are the web pages were more relevant for us, and they have to select these pages. But it does without trying to figure out what the pages are about or how they talk about the topic. They disregard it completely. They just look at how many times they've been linked by whom, linked to and by whom on the web. So the dynamic of communication. PageRank goes and sees if a page, if a page has been linked many times, according to the topic, is considered relevant to the topic. And if the page uses the link, use a specific phrase to link to the page, the system deduces, in a sense, that this phrase accurately describes what happens on the page and takes this information into account for the following pages, the following searches. So the algorithm learns from the behavior of the user producing these links. So in a sense, the algorithm PageRank is designed to capture and reflect the choices made by user using the links that we produce moving on the web. Or as John Andrea at Google says, Google does not intend, when you make a search about Einstein, for example, Google does not intend to tell you what is important about Einstein, doesn't even care about it, doesn't even know what Einstein is or who is. It just wants to tell you what humanity is looking for when it searches for Einstein, how the communication of Einstein develops on the web. And that's where Google gathers all the information, the clues that it uses to produce the search results that we get. So the intelligence of the system, the intelligence that allows Google to produce its result, remains the intelligence of the users. And the algorithm exploits it, so to say, in a sense, to direct and to organize its own behavior. So it's not Google, only Google. Google has become a kind of example, a prototype in the sense of an approach that you can find in many other successful projects on the web. And even since like 20 years, people use the term Googleization to describe this kind of approach, the approach used on the web in an increasing number of application contexts, or models that instead of relying on experts, change their approach and feed, so to say, on the dynamics of the web to organize, to learn, to improve their behavior. This, of course, leaves a lot of questions, nevertheless, open. I will want to mention a couple in the last part of my talk, which is connected with the idea that machine learning algorithms are black boxes. Let's assume we accept this shift from intelligence to communication. What happens, what changes if we use this communication-oriented approach? What do we see, what do we don't see, what we see differently if you observe algorithm shifting the focus from intelligence to communication? Especially if the algorithm we are dealing with are, in the most case, the most advanced one, the most successful now, are, as people say, opaque algorithms, are black boxes, and transparent to the real mind, to the human mind. That's the challenge, I think, that this new approach is posing to us. If machines now work in a way that is different from our intelligence and is often incomprehensible to us, how do we control the result of their operation? If you don't try to reconstruct intelligence, rely on communication, how we can control machines that we don't even understand? And it's a big problem, because let's assume algorithms work very well, and in many cases they are really very efficient. They are black boxes, and that's not reassuring at all, especially because we don't trust these black boxes completely. In many cases, we know that the operation of the algorithm have biases, make mistakes of different kinds, or even the result they produced are wrong or are inappropriate for the context. Maybe they are right, but wrong in the context, or they are right for wrong for other reasons. You know, the topic has been discussed. I don't go into that, but probably like overfitting, algorithm blindness, and very, very diverse forms of bias that we can find in the work of algorithms: systematic bias, confirmation bias, data bias, and so on. There are reasons that make us so suspicious about the result of algorithms, and we would like to be able to verify the results of the process of the machine, that we actually can understand. That's why we are talking about artificial intelligence, And the branch of artificial intelligence, which is more relevant today, which has more development, is the so-called explainable AI. So a research that tries to address these concerns about how to deal with the intransparent algorithm by developing procedures that have the aim to explain the operation of self-learning algorithms. And they produce amazing, interesting results. But it is, if we accept this approach, it is really, again, a very difficult task and also self-contradictory task because there's a basic obstacle to the effort to explain these machine learning algorithms. In a sense, the effort, if you try to have a procedure that makes human beings able to understand how the machine works, the process is basically hopeless. Because if you follow what I said up to now, it is true that the process of recent algorithms rely on the fact that they don't work like a human mind, and in a way that for human beings is impossible to understand. The machines are inherently incomprehensible. So how can you explain something which works so well because it's not comprehensible to human beings? It's not just a detail, it's the very reasons for the success of this algorithm. David Weinberg wrote a couple of years ago that requiring explanation from machine learning procedures would amount, I quote, to forcing the artificial intelligence to be artificially stupid enough for us to understand how it arrives at its conclusion. So if explainability would be making machine stupid, but you see, we are caught in a sort of contradictory effort. So the strategy must be different. And that's actually what's going on in the field. And I think it's interesting because so one is biased about one's own idea, but it shows that they are moving towards, since intelligence can be explained, they're moving towards trying to produce a kind of a successful communication. An approach compatible with the obscurity of the algorithms. So the idea would be the new process of explainable AI are actually not really concerned with intelligence. The goal is rather to produce but that's a quote from programmers, machine learning programmers. They want to produce a condition of dialogue between the algorithm and the user, in which the machine produces responses, but taking as input the requests for clarification by the users. So the idea, I should be a little quicker, I try to be not long, but the idea to make the machine able to participate in a meta communication, a communication about the ongoing communication, and thereby producing explanation for the users. So the machine, the goal is that the machine should be able to produce explanations responding to the request of the interlocutors. So the user must be able to participate in communication and to communicate about what's going on. And that's actually what we do when we produce explanation. If you think about human communication and human process of explanation, it can happen to us every day that we are requested to give, we take decision, we process operation, we do something, we take decision, and we have to explain what we did. So we have to give clues to our partner about clues that make the partner able to make sense of our decision. But when we get an explanation, we don't get information about what's going on in the brain of the person, not even in the thoughts of the person. The explanation is successful, not because disclosing what happens in the neurons of the person, and not even because disclosing exactly what are the thoughts of the person. Explanation, here I would refer to Rahmen, are reformulations with the added benefit of better connectivity, which is when the speaker produces an explanation, he or she produces a new communication that gives some additional element that is related to the request by the partner. So the idea is to produce a communicative process that doesn't need to access the brain of the partners, but just to get clues that allow the people receiving the communication to make sense of what's going on, so the communication can go on in a controlled, non-arbitrary way. And that's what's going on now in explainable AI. The most recent project explainable AI has as a goal is to produce machines that don't disclose the inner processes, which are understandable for us, are and must remain obscure, opaque, but rather to produce reformulation that match the demands of their interlocutors, of the partners. So produce a formulation that allow us to control how the machine works and to use the results in a controlled way. They say they produce post hoc explanation. So they don't explain their processes. Well, actually, also when we produce an explanation, we don't explain our thoughts, but we produce another communication that helps our partner to understand what's going on. And that's what explainable AI is trying to produce this. Allowing the machine to, to produce another communication that's, as I said, is a meta communication, refers about what's going on in a way that makes sense for the user, not necessarily for the machine itself. And the result is a condition where the user understands the explanation, but without thereby understanding the process of the machine. What the user understands is something different. I can still not have access to the process of the machine, which are opaque, obscure, and transparent, but still understand what's going on. And that the goal of this new approach is that, it seems to me, show that what's going on with the programs is not actually producing a form of intelligence that are and has to remain transparent to us, but rather to produce an alternative form of communication with communicative means to have it go smoothly and to control the procedures also for us as users of the machine. And I will stop here so we have a little time for discussion. Thanks a lot.
Yes, thanks a lot, Elena Esposito. I had to think about science fiction. It had a bit of science fiction because if we just imagine that the not understandable processes in the machines could be an alien intelligence, and we are not possible to establish channels for communication. It's a Stanisław Lem in Fiasco. It's a novel about that. But maybe this is a bit far for the topic. I just wanted to open a bit up the associations for the science fiction topic that may be behind that. They do something we don't understand, and they can simulate communication, but what do they think? Okay, I open the discussion.
Maybe I reply shortly to that, because you're addressing something which is always present in the debate, that on the one hand, there's a Turing test. On the other hand, the fear of the so-called singularity. We want to check the machine becomes intelligent, but we have the impression that the machine is becoming too much intelligence. We are scared. The singularity machine is more intelligent than us, and that would be a disaster or a scary thing, according to you see that. But actually, I don't think that's really the problem. That also worries me, because the machines are not intelligent. They want to be intelligent. They don't try to be intelligent. That's not that. There are many dangers connected with algorithms, where the inability to control them, the fact they are intransparent, that in many cases they can have a dynamic that we cannot really be able to manage in a sense. But the idea that the machine has its own or the competition between you as the machine really doesn't grab me. I'm not worried about that.
Okay. Please, though, there is a post. I don't know if it maybe you, Herr Grebe, maybe you want to tell us, or should we read the quote, the post, and just tell us, and the rest, please, if you want to say something, please write it in the chat. I can't see all of the pictures.
I can. The question is more or less formulated. As you explained, you are quite big expert in time phenomena. And my point is that algorithms do things not only better, but also faster than humans. And this means that we, using this kind of machine, we use many machines that are stronger than men. There are, and in particular, at this point, they are faster than humans. And my clear point is that real world action is time critical. For example, if you go to a concert, hear concert music, the musicians and the director make probes before and discuss it, how to play it. But if they play it in the concert, it is time critical. Or if you go mountain climbing, it is time critical because you cannot think about, if you think 2 minutes, then your partner is laying down and is dead also. So my question is the time dimension more important for algorithms than, even if it is more perfect than I mentioned, the repetition dimension? And even more, is this the most important difference between Web 2.0 and Web 3.0? You didn't mention Web 3.0, the semantic web. This was the giant global graph, and so this I somehow missed this order. But what's about this time dimension?
Yeah, thanks a lot. Well, that's a very interesting, complex question. Well, Web 3.0, I also was following the semantic web because it's such an interesting idea. And then I was wondering what happened with the Web 3.0. Nobody talks about it anymore. Until some people said that even the creator of the thing said, well, the Web 3.0 is already there because it's not a semantic web anymore, because the machine don't need to understand it anymore. They work as if they understood. So the semantic web took another form. But there's a side question to your question about time. I thought about time that the temporality of course, the machine do things much faster than us. That's, of course, there's no doubt. And but there's still the continuity between human ability and the ability of the machine. In the sense, if you look at the tempo of the machine, how fast they are, it sort of goes on the old but still fascinating idea of Marshall McLuhan, that media and machine are extension of senses, extension of human abilities. They can do, they are able to see better than us, to touch better than us, and to be faster than us. And they can do things in a way that are inaccessible for us. Until, I think in our cases, they are not even faster than us. They don't have any temporality. The temporality of the machine, well, I was thinking about the discussion about memory and forgetting. When temporal issues are translated in the machine, they take a completely different form. You know the debate about memory and forgetting. For us, the problem is being able to remember, and that's the problem has been the problem of our society since ever. And if you don't devote attention specifically to content, they simply go by themselves. Forgetting is the default. Forgetting goes by itself, and remembering requires attention. On the web is the opposite. On the web, our experience is that usually everything is remembered, and there's a lot of discussion about that. And what requires decision and a specific action is to forget, not to remember, to delete. Think about your emails. Everything remains there. You have to decide if you want to forget something, otherwise everything remains there. And that's a way to deal with time, permanence of development, which is completely different from our human mechanism. And and that's mysterious. That's, by the way, is why we are developing our project, our prediction. because the idea is that the way in which algorithms deal with time and produce predictions is that, again, really different from the way we are used to produce prediction relying on probabilistic procedures. Algorithm procedure identifying patterns and making prediction on the basis of patterns they find in the data. They do something that has nothing to do with our way of producing predictions. But there's only part answers the question.
Okay.
Can I add a question to this, or maybe others?
Yeah, if you would just have a short question, just to the point.
Yes, the short question is because time is important for action. Take, for example, high-speed financial trading. They use algorithms, they use all this artificial intelligence, and of course, those people that are that it's in milliseconds and so on, that they are changing the world with these algorithms. And one of the phenomena in this, for example, was that they used algorithms where mathematicians proved that those algorithms are very good if it is uniformly randomly distributed. And the effect was in 2007, for example, with this crisis, that people use the same algorithm. So this assumption that they are randomly distributed was more or less wrong in the execution of the algorithms. And I think this time dimension is very important in the real action that are happening where the tools of the web are used for action.
Yeah. That's definitely an important point. I reform it slightly different, and I agree that the use of algorithms made one dimension we know about prediction really clear: the performativity of prediction. As a sociologist, we always know about self-fulfilling, self-defeating prophecies, and we know that many predictions, even especially if they are right, becomes wrong because they are put into action. And that's partly what happened, according to many people, on the financial crisis, because there were this actually so reliable prediction formulated also by algorithms that they said that the exception is so minimal that it was impossible to happen. And this contradiction of the prediction came through precisely because the prediction had been formulated. So that the prediction has effects. So that was Donald Mackenzie's studies, for example, the performativity of the prediction. That by the very fact of being formulated, the prediction changes the future it's meant to predict, and thereby sort of contradicts the prediction. That's a dimension that we know from since long, but with algorithm becomes much more clear.
But the prediction that is true now may be wrong after 2 seconds.
Yeah, because it's so far, sure.
Okay. There are other questions. Lutz Hagen first, and after that, Rushandra Theodorescu.
Yeah, thanks a lot, Elena, for your very inspiring and clear talk. I like your view and actually share it that so-called artificial intelligence doesn't have in common many things with human intelligence. I'm also not afraid of strong artificial intelligences threatening us, and I also see the real problem in understanding decisions being made by AI systems, which have become successful when the paradigm of subsemantic processing has become the dominating paradigm, which means that we really, as humans, have a hard time to follow these very fast and very manifold decisions. So my question to you is, and what I do think is the point of the core of the matter, that machines don't process meaning. Yeah, if you view it from a semiotic way, yeah, they process signifiers, but they don't know anything about the signified. Yeah? And this is why it's a very different way of the way human minds work. My question is, does it make sense at all that we talk about artificial communication then? Because this is the term that you chose, at least for this talk. I'm a communication scholar. In our tradition, we have developed a concept called parasocial interaction, which is really about how people would interact with TV personalities, yeah, where there are no personas, where there is no real interaction possible. And of course, yeah, like intelligence, there's also a multitude, like for intelligence, there's a multitude of definitions for communication. But I would say communication without meaning doesn't make sense, and it's not a definition of communication that I would support. So shouldn't we rather talk, about parasocial interaction?
Mm-hmm. Well, that's a very important basic question. You are absolutely right, and I agree on many. I know that it's risky to talk about communication, so I can tell you, and I know the problems with that, and I can tell you the reason why. Nevertheless, I think it will make sense to explain what's going on. Of course, we get the question how you define communication. And if communication is just, I think you agree with me, some people understand what is meant semioticians also. Communication simply when you communicate when you get some information. And I would agree that we communicate then with the objects in the external world. I would agree that we communicate with I don't communicate with my watch, even if my watch gives information. So it's not enough for me to talk about communication. And I agree with you, meaning has to be included. But then, I'm a Romanian, I'm a system theoretician, and I, since decades, I think about communication in human sense, meaning communication is defined in human sense starting not from the producer, but from the receiver. So communication happens when someone understands the behavior of someone else or a text or something as Mitteilung of an information, I will say, you can write an entire book and put in your closet. If it's not read by anyone, it's not communication. But if I interpret the behavior of someone as I think this person wanted to communicate to me this information, which includes meaning, of course, and I attribute it to that person, to the behavior, the right of the person, whatever, then communication comes about. Which means that the thought of the person are very indirectly involved. I assume that the person has thoughts, but the communication is that if I understand the behavior as a communication, it's everything happening in the mind of the receiver. If I interpret a behavior as communication, socially, communication comes about. Even if the person didn't want to do that, didn't want to communicate, has something in mind which is completely disconnected with what I interpret out of its behavior. Which allows us, in this case, I think, to think about communication that's why the communication all requires human being. Communication happens when we understand what the machine says as something producing communication. The machine doesn't communicate with us, we communicate with the machine. So the meaning has to be involved. When we interpret the behavior, what we get from a machine as communication, which actually is related to the meaning always produced by someone else, because the machine processes the meaning someone puts in the web, processes it, and produces something which is different from that, but is still connected to meaning. So meaning is the starting point, meaning is the end, but what happens in the meantime is not connected to meaning, and communication is there only. A machine interacting with another machine, in my understanding, wouldn't be communication. You need the user interpret as communication what the machine produces, not the machine itself. And I'm interested in that because I'm a sociologist. I want to happen to see describe what happens in society. And my point was not, is a machine intelligent or not? I don't care. We have billions of intelligence already. And once more, it's not a question that grabs me. The question that what I want to ask is, what happens to the circulation of communication when machines are playing a role? How can we interpret and describe what's going on now when we actually have communication not only through talking, not only through text, but also through machines information, which actually affects the communication worldwide? That's why I thought, try to experiment with the idea of artificial communication, which is independent of intelligence, could be productive to explain what's going on.
Thank you. That was very clarifying, I think. So there is a question of Rushanda Teodorescu, please.
Yeah, hello. Thank you so much for your talk. First of all, it was very interesting for me, especially because I have been looking into the black box theory and how pretty much all of life could be considered a black box, and that we don't unlock it yet, and we don't know where the intelligence comes from. And my question is also regarding the case of black box AIs that are computed similar to neural networks. How, if they remain incomprehensible and unexplainable to humans, how do we test or try to test their intelligence, if not through the ability to communicate with us or to exchange information effectively between these two sources? Or do we even try at all to test intelligence in these cases? Or does this just go off the table?
Yeah, you're absolutely right. And I agree, especially with the first point. You know, all the metaphors refer to machine still, even with black boxes, still refer to intelligence. And also, for example, the new not understandable algorithms are called neural networks, which is a really strange idea because, as you rightly said, we have no idea how our brain works. So taking as a model something we don't understand to build machines that it's a strange idea. No? We try to reproduce something we don't understand, and how can we control the procedure? No? I think we need a more complex way to deal with that. And the question is exactly the one you ask. How can we test this, how the machine goes on? And that's why explaining about AI is on the one hand, the important thing, but it's also one of the reasons why I'm so interested in prediction, because prediction has become now the hype working with algorithms. And so, to put it very simply, how can you deal with something that you don't understand? You cannot explain what the machine are not explainable. And the people in machine learning are now saying, well, explaining and predicting are different things. Machine that you cannot explain can be still used for prediction, because you can have prediction even if you don't understand how the prediction works. And the question becomes, as I understand your question, how can I check that the prediction is right, even if I don't understand it? And the debate, you know how we talk about the correlation, causation, so on. The machine works with correlation, and correlation are often enough to make prediction. If I know that, well, every time that the number, that's a typical example, that the number of ice cream is rising in a country, there is a predictor that forest fires will also be rising. So we know why, because that what happened in summer, but the correlation is enough to predict what's going on. If you don't understand the reason, if the correlation is correct, I can predict if I cannot understand. And that's what people are doing now in machine learning. They're focused on prediction much more than on understanding. And think about the medical field. If you have good correlation, if a biomarker tell me the symptom will reliably produce a certain outcome and can predict the outcome, who cares about the causes if they are needed? If I can predict, well, I care about that because I need to explain that. But first of all, to save lives. If the correlation is reliable and you can have prediction, you care for the correlation, and you want to control if the prediction is correct, even if you don't understand it. And that's something which is really developing in the field. And that's the research about explanation is split from the research about prediction.
Okay, thank you so much.
Okay, are there any other questions? There is one other question from Hans-Gerd Gräbe in the chat. Meaning needs conceptual systems. You wanted?
I can read it also. This was my question because you are quite a great Luhmannian follower. My question is if wo habe ich my question? Where's my question? Oh yeah, what? Here. That meaning needs conceptual systems, and if you will communicate with computers or use computers in this communication process, this must be formalized in such a way that the computer can also understand in quotes, of course, this. And where do you see the potential for this? Because in my opinion, this is Web 3.0 and all this, and the linked open data world and all this, but you said this is more or less outdated. Where do you think, where are the points where this real formalization of conceptual systems is going on?
Well, we should talk now with the computer scientist, but I have the impression also talk with the people in the field. Well, you speak about meaning system, conceptual system, and in computer science, it is a fascinating talk about ontologies. People were the head of ontologies, how to reconstruct their field, and they were usually constructed in the form of tree structures. That's how the concept is connected with another one, and the ontology has to be coherent, so all concepts has to be connected with one another. They don't do it anymore. They don't care about it. The ontology, if they need an ontology, the ontology is constructed afterwards. The machines finds correlation, whatever it is. I made a project with even in sociology, topical models. No? You have all this data, and the machine processes the data and finds something, and then you explain it afterwards. The machine is not guided by the meaning at all. So the ontology, if it happens afterwards. We see how the machine finds regularity and patterns, and then we might use these patterns to make sense of something that we assume is in data. So the machine, I would guess, are not guided by meaning. They work in different ways.
But Google claims that the greatest point for this Alexa or for Siri or so is the giant global graph, and they have the Google Knowledge Vault and all this. And the question is, what's really happening there? So this, in your opinion, these are not conceptual systems, but something different. So my question would be, what is really happening there? But because this is really happening in the world.
No, they have conceptual graphs, of course, but the motor of Google is always PageRank. So PageRank follows links by the people, and the link that have to be understood. It looks what are people connected to when they make a search, and how the links that are most important are if you are most linked point, then your links are more important, and so on. Just the geography of links to reconstruct what then becomes the knowledge graph. The knowledge graph is sort of reconstructed afterwards out of procedures by the machine that are not guided by meaning. So they have it then afterwards because it helps process the further research. So the machine learns, but learns not well. And for the machine, also this knowledge graphs is semantically empty. The machine, the people say clearly, they don't have to understand the meaning. They just understand the patterns and the correlation. And that for us is a knowledge graph. But in many cases, also how the connection are is completely incomprehensible. But I don't think that the knowledge graph requires any semantic processing.
Okay, there's another question, Rita Jordan.
Yeah, thank you for the talk and also for the discussion, which I think just clarified a number of points. And I wanted to go back to the difference that you drew between explainability and prediction, because I'm wondering if there is not also, or if it could be worthwhile to work on how to explain prediction, you know, because even with explainability of AI, there was always the problem that like lay people can't understand code and so on. So there's always a gap between like what's happening and what we understand from it. And we're trying to explain it. So that's also a communicative effort, obviously. And even if you look at a predictive system, you can explain to me as a layperson how it predicts. I mean, you just did it basically in your talk, right? So, and I think, I mean, I'm a political scientist, so to me it matters that people know what they encountered in order to engage with it, like, because in ways, when you said you care about how technology affects us on a social level, I would say then probably the explainability efforts have to shift to a place where we can talk about what we want to predict, how, and what level of accuracy is important and enough for us, and so on, and who measures this, etc. So do you have any thoughts on that?
Yeah, I absolutely agree. You're absolutely right. That's what I said. That's a big problem. Let's see. If we accept that machine don't have to be intelligence, and we have to have a process to use these results not relying on intelligence, how can we control it? That's the issue. No? That's a political scientist or a sociologist also. That with the question we have to ask. We cannot. I would say the machines are not intelligent and they are always right. They are not always right. Very often they are wrong. And in many cases, even if they are right, the result that they produce, you know, the case of bias, so discussed, the process of the machine is right, but the result is not what we want, because it's discriminating, it's reproducing bias in the data, and we have to control these kind of things. We cannot just say we take it blindly what the machine produces, not at all. No? The question, how do we deal with that? And what I find interesting that we have a big project here in Bielefeld about explainable AI, and so talk with the people in the field. They simply say now that the entire idea of explainable AI is changing. People try to gain control of the operation of the algorithm, not by understanding how the machine works, because that cannot be understood, but by controlling in a lateral way the result of the machine. The machine has to explain something, which is, as I said, try to explain. It have to give you clues that allow you to understand what's going on. For example, in the medical field, make mistakes, and you want to understand what the machine possibly cannot see, or how the machine disconsiders some aspect for you are important, maybe that doesn't consider. Or we have a project about my project predictive policing. And of course, we want to understand how the machine decides that someone is likely a criminal and so on. And the machine delivers explanation that allow you to control the factors that are relevant for you without necessarily requiring require the machine to be transparent. You get enough clues to control what you want, even if you don't know how the machine went to one point to the other. The explanation is separate from the process of the machine. And that seems to be at the moment the only plausible way to combine how our algorithms work is with the absolutely necessary need not to accept blindly what the machine says, not at all, to have some kind of control and not arbitrarily accepting what the machine produces.
Okay, that was a really good question, and I think a very convincing answer. So maybe a last question, just to that point. How can we? What power do we have to force the algorithms or the industry to give these explanations, or to implement the possibility of these explanations in the algorithms?
You know, I declare I'm a system theoretician, so I'm really, that's already disappointed, but I think that's a political question, not a sociological one, not a scientific one. Of course, we are not indifferent for political questions, that we consider them. But I think there's of course there are so many issues that are really relevant for the development of the field. What you say, or the overpower the famous Google, Facebook, Amazon, so on, and the data are there, the data which are relevant in many cases proprietary, and we can deal with them, and the results also don't circulate in public communication, and the control is crazy, and so on. There are all these issues, and explainability as a scientific question is not enough to solve these problems. Of course, that's we can do what we can. We have to do what we can, but those are political issues that, of course, are relevant. But just I think that describing what's going on in a plausible way can also help not help, well, you know how crazy political fields now are, but can help eliminating some kind of useless discussion, or I don't know. But yeah, I don't have, of course, the solution, sorry.
Okay, thank you. So at least the system theory can provide us with claims. That's a good thing. And maybe we can talk about this later in the conference, so the next days. I guess it's really a brilliant talk and a good discussion, and many open questions. That is a good thing for a conference, I think.
Thanks a lot for the discussion. It was extremely interesting.
Okay, thank you very much, Elena Esposito, and all the audience and those who ask questions. Thank you very much, and see you tomorrow.
See you tomorrow. Thanks a lot.
Yeah. Bye. Thank you.
Bye.